This is proving trig identities from page 417, question 11. Trying to prove 11g first. It's 1 plus 10 over 1 minus 10, proving that's the same as 10x plus pi over 4. Well, I didn't know where to go with the left-hand side. It turned out I didn't need to do any work there, but I couldn't see how to simplify that nicely. I could have converted tan to sine over cos, but why would I? There's no sine over cos here. So instead I worked with my compound angle formula. I looked on my sheet, there's a thing for tan of a plus b. So I did tan of a plus b and I got tan of x plus tan of pi over 4 just using my formula over 1 minus tan of the first thing, tan of the second thing. Well, I don't know what to do with tan over x, I'm just going to leave it, but I used my special triangle, tan of pi over 4, it's like tan of 45 degrees, it's just opposite over adjacent, which is just 1. And on the denominator, same sort of thinking, it's 1 minus tan x times tan of pi over 4, which is just, as I said above, 1. Well, tan of x plus 1 is the same as 1 plus tan x, and on the bottom I have 1 minus tan x, which was the left-hand side. Perfect. Left-hand side equals right-hand side, which means it's proven the trig identity true. For 11h, I'm trying to prove that cosecant of 2x plus cotangent of 2x equals cotangent x. Well, I first started with the right-hand side, said let's make cotangent cosine over sine. I did that because I saw I had cosecant here, which means I was going to be working with 1 over sine, which probably meant I'd want some sines. And so I flipped the cotangent into cosine over sine. Back to the left-hand side, cosecant of 2x. Cosecant is 1 over sine, so cosecant 2x is the same as 1 over sine 2x. And cotangent of 2x would be cosine of 2x over sine of 2x. Well, that turned out to be great. I could have expanded sine 2x, but I saw right away I already had common denominator, and so what I did was said, look, that's just common denominator, bring them together out of sine 2x, and on the top I have 1 plus cos 2x. But I didn't know what version of cos 2x to use yet, so I just left it and made the bottom sine 2x using your formula sheet. The sine of this double angle, sine 2x, is just 2 sine x cos x. Okay, well I have sine and cos on the bottom here, but I only want sine on the bottom. That's the right-hand side. I want to get rid of cos x. So that meant changing cos 2x into the cosine version, 2 cos squared x minus 1, which was a great choice because 1 and minus 1 canceled out, just leaving 2 cos squared over 2 sine x cos x. These 2's canceled out, and I have cos squared, but a cos squared also cancels out with a cos, leaving just 1 cos on top. No coses on the bottom, just sine, and I have what I wanted, cos over sine on both sides. Since left-hand side equals right-hand side, I've proven 11h true. 11I was trying to prove that 2 tan x over 1 plus tan squared x equals sine of 2x. Right away I just thought, let's expand sine of 2x, double angle, it's just 2 sine x cos x. Then back to the left-hand side, 2 tan x. I left that for a second because I recognized 1 plus tan squared is just secant squared. And then I said, well, I'm going to get 2 tan x and secant squared. Let's change that to 1 over cosine squared. Could have changed tan x. I just didn't want to get messy with fractions and over other fractions. I could have. Might have saved some work. Anyway, at this point I have 2 of tan x over 1 over cos squared. When you have a fraction inside a division of a fraction, dividing by a fraction, that's the same as timesing by its flip. So this is the same as 2 tan x times the flip of this bottom fraction. And here's where I said, okay, now let's change tan x to sine over cos. And that was a good choice because now a cosine here cancels with one of these cosines from cosine squared. So I get 2, the sine x, and just 1 cosine, which was my right-hand side. Since I've again got left-hand side equals right-hand side, I've proven this identity true. That's 11I. 11J started with secant of 2 theta, and here cosecant over cosecant minus 2 sine. So I started with the left-hand side. It looks simpler to work with. I wanted to see what it would be. I got 1 over cos 2t. And then I thought, which version of it to use? Well, all I had in here was sine stuff, so I thought I'll use the version of cos of this double angle. I'll use the sine version, 1 minus 2 sine squared. But then I was stuck. And that's okay, because I'll work with the right-hand side here. cosecant is the same as 1 over sine. So I changed this top cosecant to 1 over sine, and this bottom cosecant to 1 over sine. And the minus 2 sine t just stayed there. So on the next line, the numerator just stays the same. The denominator, I do common denominator. So I have on the bottom, just looking at the bottom, ignore the top for a second, 1 over sine t, and then to make this 2 sine t, also out of sine t, I times the top by sine t to get sine t squared, and the bottom by sine t. And that's good because now I have common denominator. Just again, ignoring the top for a second, just leave the 1 over sine t. On the bottom, common denominator, 1 minus 2 sine squared over sine t. Well, that's good because when you're dividing by a fraction, it's the same as timesing by its flip. So I can take 1 over sine t and times by the flip of this fraction. So it's 1 over sine t times, flip this upside down, and you get sine t over 1 minus 2 sine squared t. And that's good because these sine t's cancel out because I'm multiplying. One's on top, one's on the bottom, and I get 1 over 1 minus 2 sine squared, which was the left-hand side. Since the left-hand side equals right-hand side, I've proven this trig identity true. That was 11J. 11K, prove that cosecant, I should say, of 2 theta equals 1 times secant times cosecant. I started with the left-hand side. Cosecant is 1 over sine, so cosecant of 2 theta is 1 over sine 2 theta, and I expanded using my double angle rule. Sine 2 theta is just 1 over 2 times sine times cos. And then let's see what happens with the right-hand side. Secant is just 1 over cos, and cosecant is just 1 over sine. On the top, multiply them all together, top times top times top, you get 1. On the bottom, 2 times sine times cos. That was a quick one. I've got left-hand side equals right-hand side, which means I've proven this trig identity true. The last one is 11L. Also from page 417. On the left-hand side, there's not much to do. It's just secant, and I can just make that 1 over cos, but that's it for that side. On the right-hand side, I had sine of 2t over sine t minus cos of 2t over cos t. I started with sine 2t. There's only one version of this double angle. It's 2 times sine times cos. And for the right-hand side, I had to think for a second which version of cos 2t to use. I didn't know yet, so I left it. I just worked with the two fractions and made them common denominator. This one's out of sine, this one's out of cos. So to get this one also out of cos, times the top and bottom by cos. And this one is out of cos, so times it by sine out of sine to get it also common denominator. And then what I did was said, okay, I can make that one common denominator out of sine times cos, that's the bottom. And on the top, I have 2 times sine times cos, that's cos squared. And then on the second part of that fraction, I thought, alright, I want to somehow, what do I want to end up? Just cos on the bottom, because the left-hand side was cos. So I want to get rid of sine on the bottom. And so I thought how to do that. And it looked to me like the best choice was to go with this 2 cos squared version, because when I do that, I'm going to be able to cancel out this cos squared. It's a bit tricky here. You might have thought, why didn't you use the sine version to cancel out sine? Well, I already saw that I was going to factor out this sine. I have a sine in this piece and a sine in this piece. Still true here. I have a sine here and a sine here. I was going to factor that out. So I used the cos version of this rule. I replaced cos 2t with 2 cos squared t minus 1. And then I did that thing I said. I pulled a sine t out of here and out of here, put it in front. This sine t comes out of both terms. Sine t is in front. What's left? 2 cos squared. And that's why I use this version here, because now I have 2 cos squared here. I rainbowed this minus in. Minus 2 cos squared, and minus times a minus 1 is a plus 1. And that worked out perfect, because now I have 2 cos squared minus 2 cos squared plus 1. 2 cos squared minus 2 cos squared just leaves 0. And so I get 1 on top, and I canceled my sine t's out, and I'm left with just 1 over cos t, which of course was my left-hand side. So since left-hand side equals right-hand side, once again, I've proven this trig identity true.